Alright, the last chapter, chapter 10, the last section of chapter 10 is 10.7. Here we are starting to work with our complex numbers and looking at properties, evolving them. So, let's begin by looking at number 88. I'm on page 768, the chapter review. We have 5 problems set aside. So, instructions. Express each number in terms of I and simplify if possible. So number 88, we start off with the square root of negative 63. Square root of negative 63. So let me remind you that negative 1 is the same as saying, the square root of negative 1 is the same as saying I, and I squared is equal to negative 1. Okay, so the square root of negative 1 is I, therefore I squared is negative 1. So the first thing you want to do when you're simplifying and working these problems is always take out the I first, or the negative. So this has a negative on the inside of this square root. And normally in our real world, or your real plane, you can't do that. But over in the complex plane, you can. So the negative comes out, and he is literally just I square root of 63. I square root of 63. Now let's simplify 63. So let's see. The square root of 63. 63 is the same as saying, isn't it 9 times 7? 9 times 6 is 54. Good. 9 times 7 is 63. And 9 is the same as saying 3 times 3. So this is the same as saying I times the square root of 3 squared times 7. Now, the 3 is being squared, so the square and the square root cancels, and the 3 comes on the outside. However, the 7 stays on the inside. And it's custom to put the constant term first. The number comes first, then the I. So this basically says 3i square roots of 7. Great. Let's move on down to number 89. And we have negative square root of negative 8. Well, like before, the first thing you want to deal with is the negative inside the square root. It basically comes out and it becomes I. So it's negative I square root of 8. And then, of course, you want to simplify the square root of 8. And I'm going to go straight to it, work it out on your problem, on your paper if you do not see it. It's the same as saying negative 2i to square root of 2. So negative 2i to square root of 2. Good so far. Let us keep going. Alright, let's go to number 91. Number 91. It says, perform the indicator operation. Write the result in the form a plus bi. So it is 8 minus 3i minus 17 minus 7i. Okay, well, first thing first, I have a minus sign in front of the second group. So what I'm going to do is change it to a plus sign and change all the signs on the inside of the second group. Is basically distributing a negative. So plus, negative, positive. So then all I got to do is add my like terms together, because basically now I'm adding my two groups together. So 8 plus negative 17 is negative 9. Negative 3i plus 7i is plus 4i. And they say write your answer in the form a plus bi, and there it is. Now on down to number 95. So 95, it still says perform the indicator operation. Write the result in the form a plus bi. So we have 7 plus 8i times 7 minus 8i. So this is just like before. We're going to do this using foiling, which is basically each term in the first group multiplies each term in the second group. Basically, everybody dances with everybody else. So 7 times 7, that's 49. 7 times negative 8i is negative 56i. 8i times 7 is plus 56i. Remember, treat I like it's a variable. It literally is a variable. It represents something, but for now I'm just going to carry it around with me. And then 8i minus 8i is minus 64. Well, I times I is I squared. Just like when we did x times x, that was x squared. Same thing holds here. I times I is I squared. The middle terms cancel out, and I have 49 minus 64 times, well, I squared is the same as saying negative 1. So that's 49 plus 64, which is equal to 113. Now they said to express my answer in the form a plus bi. Well, in order to do that, I'm just going to add 0i. Since there wasn't an imaginary part, or this bi part, I just put a 0 there. It basically is a placeholder. Alright, one more problem for us to work on. Number 98. It is actually more involved than all the other problems in section 10.7. 3 plus 4i divided by 4 minus 2i. So if you think back to when you were rationalizing your denominator, your goal was to get the radical out of the denominator. Well, the same thing holds here. Your goal is to get the I out of the denominator. You do not want an imaginary part in your denominator. So how do you get rid of it? You multiply the top and the bottom by the conjugate. So I'm going to multiply the top and the bottom by 4 plus 2i and 4 plus 2i. Now, unlike before, the conjugate actually, for a, I'm going to use the lowercase, a plus bi, the conjugate is a minus bi. You change the imaginary part. So if the imaginary part has a positive sign, like adding, then you're going to use the minus sign. If it already has the minus sign, then you're just going to use the plus sign. And if there is just an imaginary part by himself, then its conjugate is negative bi. Literally, it's positive up here, so you must use the negative. Alright, so I'm going to multiply like before. And I'm going to multiply this out, and you multiply out in your paper. Make sure, just basically verify that you get what I get. So I have 12 plus 6i plus 16i plus 8i squared, all divided by 16 plus 8i minus 8i minus 4i squared. Well, let's clean up the top. I have 12 plus 22i plus 8 times negative 1, all divided by, well, the middle terms cancel out, and I have 16 minus 4 times negative 1, and we can keep working. We have, what is that? That's going to become 4 plus 22i divided by 20. Okay, now your answer needs to be in the form a plus bi. Literally separate it. So if 20 is dividing this entire thing, 20 is going to divide each piece. So that becomes 4 over 20 plus 22 over 20i. And then, of course, we can simplify this. That's 1/5 plus 11 over 10i. And there's your final answer. And as I said, is more involved than the other operations in 10.7. When you're dividing complex numbers, you cannot have a complex number or the imaginary part, the I, in your denominator. So in order to get rid of it, you need to multiply the top and the bottom, the numerator and the denominator, by the conjugate. And the conjugate is just basically changing the imaginary part. If it starts off positive, then now it's going to be subtracting. If it starts off subtracting, the conjugate's going to be adding. Okay, and that concludes 10.7. Let me know if you have any questions.